Hello everyone. In this video, we're going to be simplifying a complex expression. I mean, an expression with complex numbers. This kind of combines a couple of things we talked about in the lecture series. Remember, we just recently finished the lecture series on complex numbers on our channel, aplusbi. And then this will be the first problem that we're going to be solving. And I wanted to combine a couple different elements here, such as division, addition, and also some other stuff. Of course, division involves conjugates, and then, simplifying will involve addition and subtraction and so on and so forth. Anyways, let's get started. We have 7 plus I divided by 2 plus I, and then that is added to 1 over 3 plus I. We did not necessarily talk about how to find the reciprocal of a complex numbers, but you can consider that a division problem and always proceed with the same method. And remember, we multiply the top and the bottom by the conjugate of the denominator, which would be 3 minus I. So remember, conjugate of a complex number a plus bi would be a minus bi. And if you use z for a plus bi, you can use z bar for the conjugate. Make sense? So let's see how we can simplify this. We're going to go ahead and start with 7 plus I, multiply it by 2 minus I, which is the conjugate. And then at the bottom, I have 2 plus I, multiply by 2 minus I. Notice that I'm multiplying the top and the bottom by the same thing, so it's equivalent to multiplying by 1. And on top, we have a 1. We're going to multiply it by 3 minus I, which is the conjugate of 3 plus I. And at the bottom, we have 3 plus I, and that'll be multiplied by the same thing, 3 minus I. Notice that we could do this problem also a little differently, which we could probably talk about in our second method. So let's go ahead and call this the first method, and the second method will be the second method. Okay. Now, when you multiply two conjugates, remember, it's a special product, and we always get a real number. So what do you get when you multiply z by z bar? You always get the absolute value of z squared. Because if z is a plus bi, and when you multiply it by a minus bi, then you get a squared plus b squared from difference of two squares, but because of I squared equals -1, it turns into a sum, and the absolute value of z is just square root of this. Therefore, the inequality, or the equation holds. Okay, so that's what you get. So this is going to give us 4 plus 1, and this is going to give us 9 plus 1. Easy, right? 5 and 10. Awesome. But what about the top? We're going to distribute. Let's go ahead and erase this thing. Hopefully you know that by now. Check out the notes or the lecture videos. I also shared the notes with you on the 9th lecture video, which is, I believe, a summary of everything. If I forgot, please let me know. I will share with you, because I made a PDF of all the stuff that I went over. So hopefully you can take a look at it. Anyways, so let's go ahead and distribute. 7 times 2 is 14, and then we get minus 7i, and then plus 2i minus I squared. Now, notice that we didn't make a common denominator, so don't add the numerators yet. Plus 5. Here I get 3 minus I, because 1 times that, and then the bottom is just 10. It's good because 5 and 10, 5 goes into 10, so that's a nice thing. Now, negative I squared. I squared is -1, so negative I squared is going to be +1. 14 plus 1 is 15. Get used to adding or subtracting I squared, because you're going to do this a lot. And sometimes, maybe most of the time, it would be very beneficial if you could do this mentally. I know you're going to get used to it if you haven't done so already. Anyways, negative 7i. Again, I'm talking too much, so I got to slow down. Okay. Now, a couple of things we can do. First of all, we can divide everything by 5 on the left-hand side. So let's go ahead and factor out of 5. It's going to give me 3 minus I over 5. And it's going to be 3 minus I over 10. 5 cancels out, and I end up with something like this. 3 minus I plus 3 minus I over 10. So I told you this is going to incorporate a lot of elements. That's what I wanted to do. Hopefully I achieved that. But now we're going to add two complex numbers. Let's go ahead and make a common denominator. Multiply by 10. You're going to get 30 minus 10i. And then now you can add them because you have a common denominator, which is 10. And then you can just add by adding the real parts and the imaginary parts. And then when you divide by 10, you should get the answer. But you want to write the answer in a standard form, which is a plus bi, where a is the real part and b is the imaginary part. Check out the lecture videos if you're not familiar with these concepts. Okay, how do you do this? You can kind of go ahead and split this up into kind of like two fractions that are being subtracted, and that will be the answer in the simplest form. So you notice that it looks like a plus bi, where a is 33 over 10 and b is negative 11 over 10. You can identify a and b easily. If there's a minus sign, that means b is negative. Okay, so that will be the answer. Let's go ahead and take a look at the second method. All right, so I'm going to start with the original problem, 7 plus I over 2 plus I plus 1 over 3 plus I. This is a very easy, like straightforward calculation problem, and I know some people are going to hate me for posting this, but here's the idea. We just barely talked about complex numbers in the lecture notes. So for some of you, maybe for most of you, it's a new topic, and I want you to be familiar with the basic problems. Don't worry, we're going to go into more complex problems later. So we're going to build this up little by little with your help, of course. So the second method involves some kind of like maybe brute forcing, I don't know, is making a common denominator. It's not desirable, but who cares, right? I mean, we can do anything we want, pretty much. So let's multiply 7 plus I by, so here's what I'm going to, maybe I'll show you here because it's a little better that way. Multiply this by 3 plus I to make a common denominator, like this. And multiply this by 2 plus I, again, to make a common denominator. And what is the common denominator? It's 3 plus I times 2 plus I, which is another complex number. Don't worry about it. Let's go ahead and distribute this. 21 plus 7I plus 3I plus I squared. Can I write it as minus 1, please? Thank you very much. Plus 2 plus I. All of that is divided by the product, 6 plus 3I plus 2I plus I squared. Let me write it as minus 1. Again, you're going to get used to this. Like I said earlier, it's very, very good if you do. Now, let's go ahead and simplify this. It's pretty much adding and subtracting. 21 minus 1 is 20. 20 plus 2 is 22. And then I have 7i plus 3i is 10i plus I is 11i. Great. And now what is 6 minus 1? That is 5, right? And then 3i plus 2i is going to be 5i. Now, you might be questioning, well, you got a totally different answer, right? Why are they so different? Don't worry, we're going to get to it. But here's what we would like to do first. You can definitely take out a 5. I mean, do you have to? No, not really. So let's not do it. But now let's multiply by the conjugate. It is 5 minus 5i here as well. And let's go ahead and distribute. We're going to deal with large numbers, but that's okay. 110 minus 110i plus 55i. Now, this is, what is this product? Let's do it mentally. Negative 55i squared plus 55. So all you have to do is multiply the numbers and negate the answer. Divided by, these two are going to give me 25 plus 25. Make sense? A squared plus b squared. That's what it is. Now, let's go ahead and simplify this further. 110 plus 55 is 165. This is going to be minus 55i divided by 50. Now, we can definitely go ahead and divide everything by 5 if we do. So let's go ahead and factor out a 5 here. 33 minus 11i. And this is going to be 5 times 10. 5 cancels out. We end up with this. And then we write it as 33 over 10 minus 11 over 10i. Let's go ahead and compare our answers. And yay, we got the same thing. Of course, you should always get the same thing. Otherwise, you made a mistake. And this brings us to the end of this video. Don't forget to subscribe, hit that notification bell, and stay tuned for upcoming videos. See you in the next video. Bye.